Okay, for this video, I want to cover something for the important unit, which is the rate equation. Okay, and in here, I want to make a like kind of a quick review, and obviously, I will talk about in different example the specific requirement. Okay, but then just most of most of them are similar. Yeah. Most of the most of the knowledge will be similar in every example, but then just important tasks is you have to know, okay, the specific point, then they may ask you that they may set a question for that. So obviously for everyone you have to know like the meaning of zero order or first order and also second order, because order of reaction for each reaction meaning is like can be zero, can be first, can be second. And then for zero you can see as a straight line or horizontal line here. That means the rate of reaction here is independent with the concentration. And then for first order, you can see as a straight line pass through origin. Then we can say rate of reaction is proportional to the concentration. That means when concentration double, rate will double. And for the second order, then you can see a curve here. That means when here change by 3 times, then the rate will increase by 9. Okay, the ratio which will change by 9 times, because you can see it's like the second order will be representing square. That's why 3 here, then here will change as a 3 squared. That means 9 times. And other than rate against concentration, for second order, they may set the special question that put a graph with rate and then concentration square. And this kind of special question has like already come up in some of the A-level exam. And then if you change the x-axis into concentration square, then this time is also proportional, because for second order, then in the real meaning, you may think is like they're not proportional to the concentration, they are proportional to the concentration square. That's why if you using concentration square as the x-axis, then you should draw a straight line and then pass through origin, which is similar to the first order reaction. But then just this time your x-axis is concentration square. And if you still get a straight line and a pass through origin, that means here is second order. So obviously for rate against concentration, then they will have a different shape, then you can easily identify their zero or first or second. But then other than rate against concentration time graph, you should have another one, which is concentration time. And you may think zero order will be like quite specific, because the only one that a straight line that will having a straight line graph for concentration time. And here, why they have straight line, you may think the rate in here is equal to the slope. So once you found the slope, then you can see the slope is like constant, which match with the hints that for zero order reaction, the rate of reaction is constant. That's why you get a straight line here. And then once you can solve the slope for this one, then you also get the value of k already, because for zero order, then rate constant is equal to the rate of reaction. So the important task will be for first order and second order, because obviously you can see like the shape are kind of similar. Both of them just the quadratic curve. So they decrease, you can say like they decrease exponentially. Then how you deduce which one is first or second order, the main thing is like only require for those example which are in not in AQA, which are in OCR, Edexcel, and WJEC. You think if you're those students, then you can learn how you can distinguish between first order and second order. If you're studying AQA, then you can just okay fine, then you can skip this kind of like techniques. So to classify these two, then you have to count one thing, which is called half-life. And the half-life in chemistry was representing the time taken for the amounts of reactant to decrease by half. So we'll take a look at here, it's like around 0.036. So the half will be 0.018. So around here, then you can say the half-life is like 1,500 seconds. And then if here is 0.016, oh sorry, 18, I mean, then the another half will be 0.008. So at this point, so it's, here is 3,000. But then if we take a look at for the half-life, we only consider from this point to this point. So it's another 1500. That means from the result here, you know that the first half-life is here, and also the second half-life will be here, and then they have constant half-life. Then once you can deduce from the graph their constant half-life, then you can say their first order. And obviously for second order, just the half-life will change, but then just no need to remember why they change or how they change. Maybe here, even I give you the result, but then just for reference, no need to remember that. And then why you have an equation here, then you think this equation is only a special requirement for OCR chemistry. Yeah, if you are studying OCR chemistry, then specifically you have to remember one extra relationship, which is you can using the half-life for first order reaction to solve the value of Gray constant. Okay, if you just like in Edexcel or WJEC, then what you have to remember just half-life for first order reaction is constant. Then it's already enough to judge the to do the correction. But then if you're in OCR, just make sure that you can recall the equation, and then using the half-life, like here is 1500, then it means 1500 equal to ln2 over k. Then once I rearrange, then I can solve the rate constant of this reaction already. Yeah. So here will be kind of a basic introduction for order of reaction. Yeah. And in the next video, then we'll try to cover some special question or some like important question that I think that they may repeat, or like for different example they may also use it.